Welcome to McPlum, simple solutions served daily.
You should start by verifying your engine and pipeline so you avoid incompatible nodes later. Next, import the complementary assets, albedo, normal, roughness, and any LUTs, so you can sample them immediately. Create a new material or shader graph and name it clearly. This prevents confusion as you layer effects. Once done, connect a base texture node and a normal map node to the material input. Make sure to enable preview shading so you can see changes in real time while you proceed. Now you'll build the complementary interaction. Create a secondary layer in the shader graph and route complementary textures into it. Choose a blend mode, multiply for darkening, overlay for contrast, add for glow, and then control its influence with a mask to isolate areas. Use procedural noise or a painted mask to avoid uniform results. After that, connect roughness and metallic drives to mixed outputs so the complementary layer affects both color and reflectivity. Finally, tweak intensity while rotating the scene light to inspect behavior. Finish by optimizing and validating. Bake layered results if you need runtime efficiency, and reduce texture sizes to fit your memory budget. Profile the shader cost and replace expensive nodes or high-frequency sampling with cheaper approximations when frame time spikes. If you see visual artifacts, inspect normal map space, ensure textures are using correct sRGB or linear settings, and check UV seams or tiling mismatch. One key tip: if colors shift unexpectedly, confirm gamma versus linear workflow and re-import textures with proper color space settings.
Thanks for watching. Stay juicy and subscribe.